Hello, today's topic is arithmetic progressions.
Here's a sequence of numbers. What do you think comes next? Here's another sequence. What comes next? What about this one? What about this one? This week we're studying things called arithmetic progressions. Which of these do you think might be arithmetic progressions? With the first three you were able to predict what came next, but with the fourth one you couldn't, because it's not arithmetic. Can you come up with a definition of an arithmetic progression? It is a sequence of numbers where each successive term is found by adding a common difference to the previous one.
What is a term? Well, there's a few things going on here. In that definition, we've referenced a term, and so each of these numbers in our arithmetic progression, we're going to call a term. I asked you earlier, can you work out what the next term is here? And it's reasonably easy, but to do so, we can work out, well, the difference, what's it going up by? It's going up by 3 each time, goes up by 3, goes up by 3, and so the next one is going to be 14. Here, our difference is -2. So I've said here that we're adding each time, but remember that we can add negative numbers as well. So you can think of that as subtracting as well. In this case, if we're subtracting 2 each time, then we know that our next number is going to be 3. What's the difference here? Well, we're actually adding 2/3 here, and 1 2/3 plus 2/3 gives us 2 1/3. That plus 2/3 gives us 3, and so our next number in this progression is going to be 3 2/3. What about this one? Well, here we've got a difference of -2, and then here we've got a difference of 2, and here we've got a difference of 8. This is not an arithmetic progression. So we're not going to be looking at sequences like that yet. We're sticking to sequences that go up or down with a common difference each time. Now, I asked you while you were tackling these questions what the next number was, and that was reasonably easy. If I asked you what the 8th number in each of these sequences is, you could find it by counting on. We could go 14, well that's the 5th number, so the 6th is plus 3 and the 7th is plus 3, so, sorry, 6 is 8 to 17, the next one's 20, and then we get to 23. And then here we're subtracting 2 each time, so we're going to go to 1, and then we're going to -1, and then we're going to go to -3. And it's possible to find out the 8th term. But what if I asked you what's the 80th term? We're going to need a rule that will allow us to determine these, what any particular term is. Before we come up with the rule, let's look at a progression in a little bit clearer ways. For us to be able to define any arithmetic progression, we need to know two things. Obviously, we need to know what the difference is. So here, this is a +3 difference every single time. We are adding 3. That's not quite enough to define the arithmetic progression, because we could also have another +3 that looks like this: 1, 4, 7, 10, or we could have another arithmetic progression that looks like 20, 23, 26, 29. These all have a common difference of 3. So in order to define our arithmetic progression, we're going to need to worry about two things. We need to know what the difference is, and also what the first term is. I'm going to explain this a little bit clearer down below. We're going to have another look at this arithmetic progression here, but I'm going to write them down this way. We've got 2, and then we've got 5, and then we've got 8, and then we've got 11, and it should be clear. I'm going to use this one here, I'm going to call term 1. That's a T with a little subscript 1 underneath it. This thing here is term 1, our original one, plus the difference. And this one here is going to be term 2 plus the difference. And term 2 is term 1 plus the difference. So we can write that as term 1 plus the 2 difference plus the difference, which we can write as term 1 plus 2 times the difference. And this one here we can write as term 3 plus the difference, which is the same as term 1 plus 3 times the difference. Let's have a look at what's happening here. In each case, we are adding a certain amount of the difference. That makes sense, because here we're adding the difference, adding the difference, and adding the difference. So let's go back to my original question, which is, what is the 80th term? Well, this is the second term, but we're only adding one lot of the difference. This one here is the third term, but we've added 2 lots of the difference. And so it's clear that we've added, to get to the 80th term, we're going to add 79 lots of the difference. In this case, that's 79 times 3. And we always add it on to term 1. So I can work out what the 80th term is by just saying that it is 2 plus 79 times 3. So I can type that into my calculator and get an answer of 239. I don't know what all the terms up to that term are, but I can tell you that the 80th number that I write is going to be 239. Let's try and generalize that. That's the numbers for this particular term. But remember back here earlier when I said that every arithmetic progression is defined by the common difference and its first term. So what we can say then is that if we want to work out any term, we'll call it the nth term. Here, n is equal to 80, meaning we are looking for the 80th term, but often we're going to be referring to the nth term, where n is a variable. So if n is 5, that means we're looking for the 5th term. If n is 8, we're looking for the 8th term. And our formula is going to be, well, we can work it out from what's here. We always start with our first term, so term 1, plus how many lots of the difference? Well, if we're looking for the 80th term, remember how when we were looking for the 80th I did 79? I'm going to put that in brackets and write n take 1. So we're just subtracting 1 from whatever term we're looking for. If we're looking for the 80th, we subtract 1 from it, and then we multiply that by the difference. This is a really handy formula because it'll allow us to work out any term in an arithmetic progression if we know the first term and the common difference. So quite often that's a skill. There's going to be lots of questions that might give you an arithmetic progression, something that just might look like 2, 7, 12, 17, and it's going to ask you what is term 1 and what is the difference. The difference is often written as D, sometimes it's written as CD for the common difference, but for our course now we're going to just be writing it as D as our difference. Alright, so what is our term 1 in this case? We know that we're just looking for our beginning term, just whatever comes first is our term 1. What is our difference? Well, for it to be an arithmetic progression, the difference is the same every single time, and so we just write that down. It's a very basic skill that is important for you to be able to do to identify what is the first term and what is the common difference. There's lots of things we can do with this formula, but one of the other simple ones I'm going to show you now, a question that you might get asked, is something that looks like this. If the third term of a sequence is 5 and the 7th term is 29, what is the first term and the common difference? So in this case, we're not given the sequence, we're not given any of the terms apart from 2 of them, but they're not next to each other. Now, there's 2 ways to do with this. One is the practical way, which is to just think, okay, well, I've got the third term, which means something goes in the first term, something goes in the second term. That one is 5, and then we've got the 4th term, the 5th term, the 6th term, the 7th term. How many lots of the difference is that? We know that the difference must be the same each time, and that is 4 lots of the difference. And that difference adding on, what's 29 take 5? 4 lots of the difference is 24, and thus the difference is 6. And so going backwards, that means that that number there has to be -1, and going backwards again, that number there has to be -7. So that's an acceptable way to do it, but it's really not the best. We can work out that the difference is 6, and the first term, T1, is equal to -7. We can work that out just from practicality. That method only really works if the numbers are small though. For example, that method wouldn't work if we were told what the 23rd term was and the 105th term. We wouldn't be able to count that much. It would be too complex. So let's think of an algebraic way, because algebra is always going to be a useful tool in this situation. Remember our formula back here that tells us that Tn is equal to T1 plus n minus 1 lots of D. Let's write that out again down here. Tn is equal to T1 plus n minus 1 lots of D. Well, I've got 2 terms that I can now sub into that formula. So for example, I know that the third term is 5, that means that when n is equal to 3, t3 is equal to 5. The third term is 5. Subbing those values in gives me 5 is equal to t1 plus n minus 1, which is 2, lots of d. And doing that again, telling me that the seventh term is 29, I can say that 29 is equal to t1 plus 6d. I've got two equations. I can solve these fairly simply with simultaneous equations, because if I call this one equation 1 and this one equation 2, then I can subtract one from the other and I can get equation 2 minus equation 1 gives me 24 is equal to 0 plus 4d, so 6 is equal to d, and thus from plugging that value of d into equation 1, so sub into equation 1, gives me 5 is equal to t1 plus 2 times 6. Subtracting 12 from both sides gives me negative 7 is equal to t1. Now that method on the right may seem a lot more complex, but it's going to be really useful later on when we're dealing with bigger numbers. So you are going to have to brush up on your algebra skills and simultaneous equations to remember how to do these sorts of problems. Pausing right now and practicing some of the exercises that you've been given would be a really good idea before we move on to have a look at some of the other problems we can tackle. Another really common thing that we need to do with arithmetic progressions is add them together. So for example, we might want to know what the sum of these first six numbers of this arithmetic progression are. We can add them all together. 2 plus 5 is 7. 2 plus 5 is 7, 7 plus 8 is 15, 15 plus 11 is 26, 26 plus 14 is 40, plus 7 gives me a total of 57. But how would we do it if we were adding to 100 terms? We wouldn't want to have to do it manually. So once again, algebra can help us if we can come up with a formula for what is the sum of an arithmetic progression, given how many terms are in it and the first term and the difference. To explain this, it's actually easier to think of a better way of adding. And what I'm going to do is pair up the first term with the last term in what we've got, and you'll notice that 2 plus 17 is equal to 19, and that 5 plus 14 is equal to 19, and that 8 plus 11 is equal to 19. If we pair the first and the last term together, we're always going to get a common sum. And that sort of makes sense because we know whatever we get from that 2 plus 17, whatever we get, the next term, which is 5, has to be 3 more than that 2, plus 14, which is going to be 3 less. So that difference, since it's always the same, adding the difference on and adding the difference on here and subtracting the difference there is going to give us the same result. So we're always going to get this pair, which means it's really, we just have to work out what that number is, which is always going to be our first term plus our last term. And then we have to multiply that by the number of pairs we've got, which are the number of pairs divided by, which is the number of terms we've got, n divided by 2. That works for everything, even if we're not dealing with an even number of pairs. Let's look at a different arithmetic progression and give you an example. Let's have 1, 5, going up in 4s, so 9, and 13, and 17. It's clear that 1 and 17 make 18, and 5 and 13 make 18. So we've got 18 plus 18 plus, well, this one doesn't have a pair, but by definition it must be half of whatever our total was. So in this case it's plus 9, which is the same as, remember back here we had n over 2, here we've got 5 terms, so it's 5 over 2 or 2.5 lots of 18, meaning that we've got 2.5 pairs and each of those pairs adds up to 18. This formula is really useful, but it's actually usually written another way, and the reason it's written another way is we don't want to always refer to Tn, which you then have to calculate first. So what if we just substitute our other value in for Tn? You'll often see something like this. The sum of an arithmetic progression to n terms is equal to n over 2 lots of T1 plus the formula for Tn, which is T1 lots of n minus 1 times d. T1 plus n minus 1 lots of d, and that's equal to n over 2 lots of 2 times the first term, 2t1, plus n minus 1 lots of d. That's our formula that we're going to use quite a lot to add a number of terms. Let me give you an example of that. Let's have a look at this arithmetic progression. 60, 55, 50, 45, 40. We want to know if we add or find the sum of the first 15 terms, what are we going to get? Now we could write out all 15 terms and add them with our calculator, but it's easier to plug our values into this equation. Now before we substitute it in, we like to write out very explicitly what we found out, the values we're plugging in, so we know that n is going to be equal to 15 and that T1, our first term, is going to be equal to 60, and that D, our difference, is equal to -5. This is incredibly important to write out because anyone who's following along with your working, if you make a mistake with the substitution, at least it's clear where your mistake is. If you don't write that bit out, then it makes it very difficult to follow if you've made a mistake. So in this case, our sum, that's an S, sum to 15 terms is equal to 15 over 2 lots of 2 times the first term, which is 60, plus n minus 1, well n is 15, so that's 14, lots of the difference, which is -5. So 15 over 2 is 7.5, lots of 2 times 60 is 120, plus 14 minus 5 is take 70. That gives me an answer of 7.5 times 50, which is equal to 375. Have a go at some of the next set of questions now.